Exam 1 Review, Sections 1.1 through 2.6. Okay, number 1 says to solve 15x plus 29 times x minus 3 equals 221. Okay, so here we want to distribute the 29. We have 15x plus 29x minus 87 equals 221. Okay, so now let's combine like terms. We have 15x plus 229 is 44x. Bring down minus 81 equals 221. We want to isolate the 44x, so if I have minus 87, we'll do the inverse and add 87 on both sides. And so we have 44x is equal to 308. And then dividing the inverse of multiplying 44, we want to divide by 44 on both sides. And so we get x equals 7. Okay. You can check your solution by plugging 7 back into the original equation, and you should get a true statement. Okay, let's look at number 2. Number 2 says to solve for the indicated variable, we have the formula or literal equation px plus qy equals r, and we want to solve the equation for y. Okay, and it says here that q does not equal to 0. Okay, so here I want to solve for y. So first we'll isolate the qy. We're adding px, but in this case here px is a positive, so we'll do the inverse and subtract px on both sides of the equation. Okay, so we have qy is equal to r minus p times x. And here we'll, with y, we've multiplied q, so we'll divide both sides of the equation by q. And so we have y equals to r minus px divided by q. Okay, let's look at number 3. Okay, number 3 says to solve for q equal to 6/5 times t plus 21, and we'll solve the equation for t. Okay, so we want to first isolate the 6/5 t. We'll subtract 21 on both sides. We have q minus 21 equals 6/5 t. And then to isolate the t, since 6/5 is multiplied, we can either divide by 6/5 or multiply by the reciprocal. So let's do that. So we'll multiply both sides of the equation by 5/6. Okay. So on the right side, the 5's will cancel and the 6's will cancel. So we have t, or 1 times t, is equal to 5/6 times the quantity q minus 21. Okay. In this case, they'll give you some solutions. You want to choose the one closest to the answer, or not closest. You want to choose the correct answer. In other cases, you can distribute 5/6 to each term. So 5/6 times q, and then minus 5/6 times 21. Okay, 35/2. Okay, so we'll go with this one since we have solutions to choose from. And in this case here, we'll choose a, t equals to, not a, sorry, we'll choose d. T equals to 6/5 times q minus 21. Okay, let's look at number 4. Okay, number 4 says to find the equation of the line with y-intercept -5 and slope of 4/9. Okay, so here we're given our y-intercept, which is denoted by b equals to a -5, and our slope denoted by m equal to -5. I'm sorry, -5, not -5, 4/9. Okay, so if we're finding the equation of the line, we're going to use the linear equation form, y equals mx plus b, the slope intercept form, and we'll just replace our values for m and b. Okay, So we have y equals to a slope of 4/9. So 4/9 x plus b. B is a -5, so we have -5. Okay, so there's our linear equation. Okay, let's look at number 5. Okay, number 5 says a farmer buys a new tractor for $148,000 and assumes that it will have a trade-in value of $83,000 after 10 years. The farmer uses a constant rate of depreciation to determine the annual value of the tractor. Part A says to find a linear model for the depreciated value, V, of the tractor T years after it was purchased. Okay, so in this case here, we're asked to find a linear model. So we're looking for a linear equation. Let's do number 5. Y equals mx plus b. But here they let us know that V represents the value, the depreciated value, and T represents the time in years. So in this case here, our dependent is going to be V. So we'll replace the Y with a V. And then our independent variable will be T. So we'll replace the X with T. Okay. So we want an equation in this form. Okay. We're given 2 points or 2 pieces of data in this equation or in this word problem that represent 2 points. So a new tractor at 148,000 at a value of 148,000 is going to give us a time of 0 and a value of 148,000. Okay. And then it says that this tractor will have a trade-in value of $83,000 after 10 years. So our time will be 10 years at 83,000. Okay, so we'll use those 2 points to first find the slope or the rate of change in the value with respect to years or with respect to time. And so here we have m equals, instead of y sub 2 minus y sub 1 over x sub 2 minus x sub 1, we'll use v sub 2 minus v sub 1 over t sub 2 minus t sub 1. Whoops. Okay, and so our second value is going to be 83,000 minus 148,000 divided by 10, our second time, minus 0. Okay, so our slope or our rate of change will be 83,000 minus 148,000 will be a negative 6,000, oh no, a negative 65,000 divided by 10 minus 1 is just 10. Okay, so we have a rate of change of a negative 6,500, and so that'll be our change in value over time of a negative, or we reduce $6,500 for each year. Okay, or depreciate. Okay, now we want to write a linear equation. We can start with a point slope form. So instead of having y minus y sub 1 equals m times x minus x sub 1, we'll use the value v minus v sub 1 equals our slope, which we've just found, times x, or not x, t minus t sub 1. Okay, so we have v minus v sub 1 will be 148,000. That was our first value given, equals our slope that we've just found, a negative 6,500, times t minus our first time, which was 0. Okay, and we want to solve this equation for v. So we have v minus 148,000 equals a negative 6,500 times t, and then a negative 6,500 times a negative 0, that'll just be 0. Okay, and then we want to add 148,000 to both sides of the equation. Okay, so our value is given by a negative 6,500 t plus 148,000. Okay, and this is our linear model for the value of the tractor. Okay, so that's part A. Okay, let's look at part B. Okay, so here we have 5 and part B. Part B says or asks, what is the depreciated value of the tractor after 6 years? Okay, so we want to use our linear equation from before. The value is equal to a negative 6,500 times T plus 148,000. And here we're asked the value of the tractor after 6 years. So here we can rewrite V to be V of T, a value with a value as a function of time. So I'll rewrite that one real quick. Okay. And so the value after 6 years means we're evaluating the value function, replacing time with 6 years. Okay, so we'll replace all of our T's with 6, or in this case, our only T with 6. So we have a negative 6,500 times 6 plus 148,000. And so here, negative 6,500 times 6 plus 148,000 is equal to 109,000. So our value after 6 years is 109,000. Okay, so that's part B. Okay, let's look at part C. Okay, part C asks, when will the depreciated value fall below $80,000? Okay, so our value, let's put that again. So 5, part C. Our value with respect of time was a negative 6,500 times T plus 148,000. Okay. So since we're trying to determine when the depreciated value falls below 80,000, we'll set up an inequality where our value determined by the function negative 6,500 T plus 148,000 falls below 80,000. So it has to be less than $80,000. So we'll just do 80,000. Okay, and so we'll just solve this inequality to determine the time, or the time when it'll fall below 80,000. Okay, so let's subtract 148,000. Okay. And so we have a negative 6,500 T is less than 80,000 minus 148,000 will be a negative 68,000. And then we'll divide by a negative 6,500 on both sides. And remember, if you divide by a negative, you have to change the direction of the inequality. So we have T is greater than a negative 68,000. Yep, that was divided by a negative 6,500. It's approximately 10.4615 ... So in this case here, we want to put the year, and in this case, we can't put the 10th year because it has to be greater than 10, so it'll be the 11th year, okay? Okay, and in the 11th year, the value will fall below 80,000. Okay, so let's look at part D. Part D says to graph V for time greater than or equal to 0 and less than or equal to 20 years, and choose the correct graph below. Okay, so in this case here, we want to graph the value function V of T equals to a negative 6,500 T plus $148,000. Okay, and so here we know our y-intercept is $148,000. So that's one way of checking right off top, is just checking to make sure we have the correct y-intercept for the 3 graphs shown here. Okay, and so if we look at the graphs, we know here's 100,000 for each of those. Okay, so in this case here, we know we can X out B because it falls below 100,000. Okay, for A and C, we want to determine the increments between 100,000 and 200,000. And one way to do this is, I know the value, the change in value between those two are 100,000. And if I count the tick marks in between, I'll count 5. So 1, 2, 3, 4, 5. If I divide the 100,000 by 5, those will be in increments of 20,000. Okay, so I go up from 100,000 to 120,000, 140,000, and in A it falls right above that. Okay, so if I look at C, I have 100,000, 120,000, and it's just right above 120,000, but below 140,000. So in this case here, my correct graph would be A. Okay, that's one way of finding it. So our correct graph is A. You can go into your calculator and go to y equals and type in the function negative 6,500x plus 148,000. And you'll have to change your window settings. Let me put calculator to have a minimum, an x minimum of 0 and an x maximum of 20. We'll do a y minimum of 0 and a y maximum of, in this case, the graph showed 200,000. Okay, so let's look at that on another slide. Okay, so we have part D. We're still graphing the function. I'm going to choose y equals in the calculator. So you'll click on the button y equals in your TI-83 or TI-84. And then you'll type in the function. Here we had v of t was a negative 6,500 t plus 148,000. In the calculator, you'll type in y equals a negative 6,500 x plus 148,000. Okay, and so in this case here, when you choose to type in x, you'll have to type in the xt theta n button, which is a few buttons above your 7. Okay, and then you'll click on the window. So okay, click the window button, and then we'll change our scale here. Our x min, x max, x scale, y min, y max, and y scale. Okay, so our x minimum, we know it says to give a time or to choose time values between 0 and 20. So our x min will be 0. Our x max will be 20. If you count below, the increments between 0 and 10 here are 1, 2, 3, 4, 5. So if you divide 10 by 5, you'll get 2. So that's in increments of 2. So we'll do a scale of 2. For our y minimum, we're going to go, the graph shows 0 to 200,000. So we have a y min of 0, a y max of 200,000. Okay. In our y scale, we already divided the increments between, or we divided 100,000 by those 5 increments. So our y scale is going to be 20,000. Okay. And so by doing this, you'll get a graph in your calculator that looks like graph A. Okay, let's look at number 6. Okay, number 6 says use a graphing calculator to find a linear regression model for the men's 100-meter freestyle data given in the table on the right, where X is years since 1980 and Y is winning time in seconds. Okay, so we'll include another table here, and I'm going to write in the value of X for the years and the value of Y for the column for men. X is represented by the year since 1980. So if the year is 1980, the year since 1980 would be 0. For 1984, 4. 1988, 8, and so on. Okay, so let's change these values. 20, 24, 28. So our X values will be 0, 4, 8, 12, 16, 20, 24, and 28. Okay. And then our Y values will be the times that are shown here. Okay. Now, in order for the calculator to do linear regression, we'll have to type our X values under L sub 1, represented by list 1, and our Y values under L sub 2, represented by list 2. Okay. So you'll go to your calculator and click Stat. Okay. Click the Stat button. And then once you click the Stat button, you'll see Edit at the very top. Choose the number 1 to edit. Okay. And once you choose number 1 to edit, you'll see a table that looks like this. Under L sub 1, you should type in the X column. And under L sub 2, you should type in the values under the Y column. Okay. And it should look like this. Okay. And the very last row is not showing here, but the very last row should be 28 with a time of 47.21. Okay. So once you type in all of your values, always double check all of your values because you want to make sure you're doing the correct linear regression. And if there's one value off, it'll throw your equation for your line off as well. Okay. So once you typed in your list, then you'll click Stat again. Okay. And then once you've chosen Stat again, okay, you'll choose the right arrow to arrow over to Calc so that you can calculate the linear regression. And so choose 4. You'll see beside 4, LINREG parentheses AX plus B. Okay. This will give you a line that models the data that you've just typed in. Okay. And you should see this table next. Okay. But right before you see this table, when you choose 4 in linear regression, oops. Okay. You'll see linear regression in your calculator, AX plus B. You'll have to enter there first. Okay, so sorry, I forgot to include that step. And so you'll see this screen here, linear regression, AX plus B. Okay, and then you want to go all the way down to calculate and hit enter. And once you do that, you'll see this next screen. Okay, so we have the equation y equals ax plus b, and we're given an a value shown here. Whoops. Okay, so we're given an a value shown here. Let's circle it in red. Okay, and our y value shown here. Or I'm sorry, our b value, which is the y-intercept. Okay. So it says to round the regression coefficients to 3 decimal places. Here, be careful to make sure you round to 3 decimal places. So for A, we'll have a negative 0.094 since this number is 4 or less. Okay, and then for B, we'll have 50.107 since this is 6 more than 5. Okay, so we'll round that up. So our model will be y equals to a negative 0.094x plus 50.107. And this will be the regression model for the men's time. Okay, let's look at the women's. Okay, so in this case, for the women's, we'll be looking at the third column here. Okay, and this will be listed under L sub 2, and we'll have the same X value listed under L sub 1. So we'll have 0, 4, 8, 12, 16, 20, 24, and 28. Okay, so again, we're going to choose the Stat button. Okay, once you've chosen Stat, choose 1 to edit. Okay, and then you'll arrow over to L sub 2 and go up so that you're actually on L sub 2. Okay, and then you'll just clear that data. So you'll clear and then enter. So hit the clear button and then enter. Okay, this is a quicker way to clear the data from the column L sub 2. Okay, and then you'll type in the data for the women's time. So you'll have a table that should look like this. Okay, and make sure you double check all of your values as well. The very last row, which will be year 2008, so 28. So 28 here. Whoops. And 47.21. Oh no, not 47. That's the men's time. Sorry. And 53.12. You can't see here, but I do have those entered in. So make sure you check all your values and you have everything typed in correctly. Okay. So once you've typed everything in correctly, you'll then choose Stat again. Okay. Arrow over to the right to calculate. You'll choose 4, button for linear regression. Okay. And then at the top of your calculator screen, you'll see linear regression, AX plus B. Hit enter. And then you should see this next screen. Okay. And then you'll arrow down to calculate. Okay. And once you're all the way down to calculate, you want to click enter. And then you'll see this screen. Okay. And so here you'll see the linear regression model for the women's time. Okay. And just as before, we want to round the regression coefficients to 3 decimal places. So in this case here, our A is going to be negative 0.0787. Negative 0.079, because this 7 is higher than 5. Okay, so Y equals negative 0.079x plus for our B we'll have 55.56. We have an 8 here, so we'll round this to 6. So 55.566. Okay, and so that'll be our regression for women's. Okay, and then the next part says, based on the regression models, will the women's time eventually catch up with the men's time? So in order to determine if the women's time will catch up with the men's time, we'll take the two equations and set the two equations equal to one another to see if there's a value of x for which the two equations are equal. And if that's the case, that means the women's time will catch, or the women will catch up with the men's time. Okay, so let's do that now. So for the men's regression model, we have a negative 0.094x plus 50.107 equal to the women's regression model, negative 0.079x plus 55.566. Okay, and so we want to solve for x here. I'm going to add 0.079x and also add 0.079x here. And so for negative 0.094x plus 0.079x, we get a negative 0.015x, okay, plus 50.107 equals 55.566, okay, and then we'll subtract 50.107 from both sides. And so we get a negative 0.015x equals 55.566 minus 50.107. 5.459. Okay, and then we'll divide by a negative 0.015 on both sides. Okay, and so x is equal to 5.459 divided by a negative 0.015. Okay, and so we get an approximation. Let's do approximately a negative 363.933, and this represents years since 1980. So we can't go back in time to have a negative time from 19 or a time negative from 1980. So in this case here, we'll say no. The women won't actually catch up with the men. Okay, so our answer is no here. Okay, let's look at number 7. Okay, number 7 says if f of x is equal to 3x minus 8, x minus 8, find the value of the expression f of 6. Okay, so if we're finding the value of the expression f of 6, this just means that if x is equal to 6, we're going to find the value of y that corresponds. And so we'll do that by replacing all x values with 6, since we know that x is represented by 6. Okay. And so we have 3 times 6, which is 18, minus 8 equals 10. And so the value for f of 6 is equal to 10. Okay, let's look at number 8. Okay, number 11, it says the table to the right shows the electricity rates charged by better than lighting utilities in the winter months. Part A, write a piecewise definition of the monthly charge, W of X, for a customer who uses X kilowatt hour in a winter month. Part B, determine the graph of W of X. Okay, so the first thing we want to do is write a piecewise definition. Here from the table, it says that for the winter months, we have a base charge of $7.50, and then the additional first 500 kilowatt hour or less will have 0.075 per kilowatt hour. Okay, so let's write out the first part. So the first part is going to be for x greater than or equal to 0 and less than or equal to 500. Okay. We know we'll have a base charge of 750 plus 0.0750x. Okay. For anything over 500 kilowatt an hour or kilowatt hour, we'll charge 0.0900 per kilowatt hour. So in that case, I'll write this below. We have the base charge, we'll keep that, plus we know we'll pay 0.0750 for the 500 kilowatt hour, plus anything over that will be 0.0900 for anything over 500 kilowatt hour. Okay, so the way we express that is we'll say x minus 500, because if I have 700 kilowatt hour, then I want to pay 0.0900 for 200, so I'll have to put the 700 there to only count the 200 as 0.0900. Okay, let's take that 700 away. Okay, and so here I just need to simplify this equation. So we have 750 plus 0.075 times 500 gives us 3750. Plus we want to distribute the 0.0900. So we have that times x would be 0.0900x, and then times a negative 500, 0.0900 times negative 500. Okay, so we'll get minus 45. Okay, and so here we'll just combine our like terms. We have 750 plus 3750, or 37.5, minus 45. That gives us 0. So this cancels, and we're left with 0.0900x for anything greater than 500 kilowatt hour. Okay, so here's our piecewise function for that one. Okay, part B says to determine the graph. So in the calculator, in order to type in your piecewise function, we want to type in y equals in the calculator, and then we'll see this screen. Okay, to type in the piecewise function here, you want to type in 750. If you can type fractions in your calculator with alpha y equals, then that'll be fine. But if not, here the top portion will be 750 plus 0.0750x, and then we'll do divided by the bottom portion will be the inequality. Okay, so when I write in or type in the inequality, I can't do a compound inequality. So first I'll say 0 is less than or equal to x, and x is greater than or equal to 500. Okay, so the way you'll do that part in the calculator is, once you type in the top part, 750 plus 0.075x, and have that in parentheses and divide. To type in the inequality, first let's type in 0. Okay, and then to get the less than or equal to, we'll choose second in math. Okay, second in math will get us to the inequalities, and we'll choose less than or equal to, which is 6. Okay, to get the and statement, here we'll choose second in math again. Okay, but we'll choose the right arrow over to logic. Oops. And then once we arrow over to logic, we'll choose 1 to type and. Okay. Now, I forgot to mention this. This needs to be in parentheses, and then the whole denominator needs to be in parentheses. Okay. So I'll do a double parentheses right after the division key. Okay. Now we're going to type x greater than or equal to 5. So for this portion, let's do that in purple. Okay, I'll type in x t theta first, so the x t theta end button, and then second in math. Okay, greater than or equal to will be number 4, so you'll choose 4, and then you'll type 500. Okay, and then close the parentheses on that bottom portion, and then close the parentheses again for the whole denominator. Okay, this will allow you to type in or represent the first portion of the graph for anything greater than or equal to 0 and less than or equal to 500. Okay, for y sub 2. For y sub 2, we'll type in 0.0900x, and that will be in parentheses. Then we'll divide by the inequality in parentheses first, x greater than 500. Okay, so to get this inequality again, you'll just choose second in math. Okay, and once you choose second in math, for strictly greater than, we'll type in 3. Okay, and so now after that, you'll type in or click the graph button. Okay, and then you should see this image. And this is the graph of the piecewise function w of x. Okay, so here I'll just put w of x here. Okay, so you want to choose the graph that's closest to this, and in this case, part A, or A, the solution of A for part B. Okay, okay, let's look at number 12. Okay, for number 8, it says to find the expression if f of x equals x squared plus 4x. And this is number 8. For f of negative 2. Okay, so here we know x is equal to negative 2. We'll replace all of our x's with negative 2. So for x squared, we have a negative 2 squared, plus 4x, we have 4 times a negative 2. Okay, so negative 2 squared in the calculator, be careful to do an open parentheses, the negative sign first, and 2 in closed parentheses to square it, because in this case you'll get 4. But in the case where you choose to do negative 2 squared, it'll square the 2, which is 4, and then take the negative sign. Okay, and this is not the one we want there. Okay, okay, so we have 4 plus 4 times negative 2 will be 4 minus 8, which is negative 4. Okay, so f of negative 2 is negative 4. Okay, let's look at number 9. Number 9 says to find and simplify each of the following for f of x equal to 4x squared minus 5x plus 6. Okay, for part A, we want to find f of x plus h. Okay, so if I'm finding f of x plus h, that just means I'm going to replace all of my expressions for x, or I'll replace x plus h for all of my x's. Okay, so here we have 4 times x squared will be x plus h squared, minus 5x will now be 5 times x plus h plus 6. Okay, so notice here we just replace all of the x's with the expression x plus h. Okay, so I have 4 times x plus h squared is 4 times x plus h multiplied twice. Okay, minus 5 times x plus h will distribute the negative 5 here, so we'll have minus 5x minus 5h plus 6. Okay, here I'll go ahead and FOIL my x plus h first and then take the product of 4. So x times x will be x squared plus x times h, hx, plus h times x, hx, plus h times h, h squared. Okay, and we'll bring down our 4, and then minus 5x minus 5h plus 6. Okay, so here I want to combine the like terms. xh plus xh will be 2xh. Okay, and so in the case where I distribute the 4, I'll have 4x squared plus 4 times 2xh. So I'll have 8xh. Plus 4 times h squared will be 4h squared. Okay, and bring down my minus 5x minus 5h plus 6. Okay, and so here we look to see if we can simplify it. In this case here, there are no like terms, and so our answer is 4x squared plus 8xh, or hx. I'll go ahead and rewrite that. So 4x squared plus 8hx. And let's do it in descending order. So minus 5x plus 4h squared minus 5h plus 6. Okay. And so this will be f of x plus h. Okay. Part B. Part B wants us to find the difference of f of x plus h minus f of x. So in this case here, we already have f of x plus h. Okay. And then we're subtracting f of x. So I'm just going to rewrite what's boxed in over here to the right. This will be part B. We have 4x squared plus 8hx minus 5x plus 4h squared minus 5h plus 6. And then we'll subtract f of x. And so we'll look at our original function and we want to subtract f of x. And so if I subtract f of x, I'll be subtracting each term. So I'll subtract 4x squared. I'll subtract a negative 5x. So that'll be plus 5x. And I'll subtract 6. So that'll be minus 6. Okay. So in this case here, we want to combine like terms. 4x squared minus 4x squared, those cancel. A negative 5x plus 5x, those will cancel. And a positive 6 and a negative 6, those will cancel. Those are opposites. Okay. And so we're left with 8hx plus 4h squared minus 5h. Okay, so that's part B. Okay, part C says to find f of x plus h minus f of x all over h. And so I'll write it above here. Since part C is just part B divided by h, here, f of x plus h minus f of x all divided by h. I'll just take the answer from part B, which is 8hx plus 4h squared minus 5h, and I'll divide each term by h. Okay. And so here the quotient we'll have will be 8x. If I reduce or divide 8hx by h, I'm just left with 8x plus 4x squared divided by h will be 4h. And then minus 5h divided by h will be minus 5. Okay, and so my answer is 8x plus 4h minus 5. Okay, let's look at number 10. Okay, number 10 says to, smooth this over. Indicate how the graph of g of x equal to x plus 7 quantity squared minus 3 is related to the graph f of x equals x squared shown below. Sketch a graph of the function. Okay, so here we have number 10, and we want to indicate how g of x, which is x plus 7 quantity squared minus 3, is related to f of x, which is equal to x squared. Okay, so here if we look at g of x, we have a plus 7 within to the x, and that's going to be a horizontal shift. So here the horizontal shift of a plus 7 will shift left 7 units. Okay, or if you have all of your ordered pair plotted, then you'll subtract 7 from all of the x values. Okay, and then for minus 3 represents the vertical shift, and if it's a minus 3, it'll shift down. So we have shift down 3 units. Okay, so g of x is basically a transformation of f of x, where I take the original function f of x which is sketched here. And I shifted to the left 7 units. Let's do this in a different color. Okay, so let's do the original in black. Okay, so here I have my original f of x function, which is x squared. In my g of x transformation, I'm going to take my f of x, the x squared, and shift each unit to the left 7, 1, 2, 3, 4, 5, 6, 7. Okay, and then I'll shift it down 3 units. 1, 2, 3. So to shift down 1, 2, 3 units. And so I have the transformation g of x here. X plus 7 squared minus 3. Okay. And so that gives us, let's see, B. Oh, and I have it cut off here, but that'll be part B. Okay. Let's look at number 11.